Okay, so we're going to be discussing roots of polynomials. And the way that we find the roots is we want to make the polynomial written as multiplication. So multiplication, the way we do that is by factoring. Right? So we factor something, we write it as a multiplication. Now, what this does is it has this property where we have the multiplication of two things is equal to 0. So let's try it with numbers first and see what happens, right? If we have a number 2, what times 2 gives you 0? And I think it's pretty clear that if you plug in 1, 2, -5, pi, none of those is equal to 0. The only time that happens is when you have a 0 there. So the multiplication of two things is 0 only when at least one of them is 0. So we can use this property no matter what they are. It doesn't matter if it's a number and it doesn't matter if it's a polynomial or a function which has been split into its factored form. So since we know that one of the multiplications must be 0, what we're going to do is we're going to take each of the parts of the multiplication, set them equal to 0. And then go ahead and solve for the x value. So here, x is equal to -4 by subtracting 4 to both sides. Here, x is equal to 3 by adding 3 to both sides. And in this bottom one, if I subtract 1, 2x is equal to -1, and then divide both sides by 2, x is -0.5. For this one, right, what you'll see is that you can do it in two ways. You can either split the polynomial or the factored form into x plus 2 times x plus 2 equals 0. And then again, use the fact that if you have a multiplication equal to 0, one of them must be 0. So here, x is equal to -2, x is equal to -2. Another way to do it is using the square root property, which we did in the last video. So here, x plus 2 squared equals 0. If I square root both sides, you get x plus 2 equals plus or minus the square root of 0. So x is equal to -2 plus or minus the square root of 0. So the square root of 0 is 0, so you just get -2. Now what this does is it tells you the multiplicity. So the multiplicity of a root is the amount of times the root repeated. So the amount of times that this root here repeated was once. This one down here is once. This one over here repeated itself twice. And you can notice that in here, it's not quite as obvious that it happened twice, but because you have a plus or minus 0, remember you have to split it as this or that. So there are still two -2's. And this is also given by the degree of that factored portion. Now, what you need to do, just like in an earlier section where we were discussing the different ways to read inputs and outputs, you have to have a different version of reading the roots of polynomials. So here's the list. So you can get roots. Another name for those are zeros, horizontal intercept, and solutions when the function is equal to 0. Okay. So what this does, I think it's pretty clear that zeros are given by the thing you plug in gives you a 0. So that should be clear why this one is true, right? The solution to this function when you plug in is 0. The horizontal intercept, remember, is given by a point, which is, for example, that one. But the height is 0. So it's the thing you plug in to get 0. So these are all different ways to read it. A way that a student was discussing roots with me was fairly straightforward, and I thought it made a lot of sense, was you have a tree. Where are the roots? Right there. So the roots start at the base of the tree, which would give you the zeros where they touch the horizontal axis.